Hello, my name is Cyril Chan, and my chosen application for the practical exam is a quadratic root solver. So to first off, the introduction, this practical exam will be covering two topics that were covered in previous experiments to show that the student has indeed performed and learned from them. The experiment will be dealing with a quadratic root solver VI, or virtual instrument, and the student will be tested on his or her knowledge on experiment 3, which is loops, and experiment 4, which is debugging and troubleshooting. Next is the objectives. First, to apply learnings from experiments 3 and 4. Next, to fix and debug the broken quadratic root solver VI. Next is to identify and fix the runtime error in the block diagram. Lastly, to modify the block diagram so that the code will run or execute continuously. For objectives 2 and objective 3, these are related to the application of learnings from experiment 4. And the objective number 4 is related to the learnings from experiment 3. Next is the software used. The software that we'll be using is the NI, National Instruments LabVIEW 2020 software. Next is the procedure. Part 1 will be dealing with the debugging and troubleshooting, or experiment 4 application. So first, step 1 is to open the LabVIEW software. Next is to open an existing project. The next is to open the quadratic root solver project file. Then we select the quadratic root solver VI file. Next is when we run the block diagram, it is to be expected that an error list window will pop up, which leads us to step 6, where we will be identifying each of the errors and fix these errors. Then step 7 is to check with a calculator if our outputs are correct or if our solved roots are correct. Then step 8, to determine using probes where the runtime errors are and fix them. Since in using probes, we'll be able to identify where these runtime errors are occurring. Then step 9, we will be saving the VI file. Next is part 2, which concerns loops or an application of experiment 3. So for step 1, after debugging our program, we apply a while loop around it, or we encompass the program with a while loop. Next is step 2. Inside the loop, we connect a stop control to this loop condition. This stop control is a control type variable in which it will stop the while loop from continuously executing. Then of course we run the program to see if it works. Then step 4, we connect an indicator to the loop iteration and name it iterations. This indicator variable will help us identify which iteration of the while loop we are running currently. Then step 5, we run the program again. And then step 6, we save the file. And that ends the procedure. Next is the results and discussion of the experiment. So by clicking the run button, one is able to see the different bugs and errors found in the program. And this is through the pop-up of the error list window when we click the broken run button. Next is clicking each error in the error list window it highlights the concerned components. Since each error that we click in the error list window, it shows us which component has that particular error. Next is runtime errors cannot be detected through the error list window, but with the use of probes. Since runtime errors don't display in the error list window, we are only able to find out where they occur by the use of probes, since probes uh, they display the value that goes through a particular wire. Next, the sub-diagram of a while loop will continuously run until a certain condition is met or fulfilled, hence its name while loop. It will continuously run while a certain condition is not met yet. Lastly, the conclusions found with the experiment. These conclusions can be connected to our objectives of the experiment in slide 3. So by fixing each of the errors inside the block diagram, the student has fixed the broken quadratic root solver virtual instrument. Then by using probes, the student has identified the runtime errors in the block diagram and fixed it. Then through the use of the while loop, the student has modified the block diagram to make the code execute continuously. And lastly, in completing this practical exam, the student has shown an application of the learnings from experiments 3 and experiment 4. So to follow will be a quick video demonstration of the procedures of the practical exam. And that's the end of the presentation.